This is part 2 of topic 6.4, and we'll be covering the average value of a function. I also call it f average, or you could say fav. I'm going to go ahead and do that. Fav. Okay, so let's recall a few things. First of all, let's recall the average rate of change. And the average rate of change of, let me go ahead and write this here, the average rate of change of f of x from x equal to a to x equal to b is f of b minus f of a over b minus a. That's just slope. Wonder if I can get this minus a little bit nicer there. Okay, now let's talk about the mean value theorem. And this is something that it just sort of makes sense. But basically, it says that if f of x is continuous on AB, on that closed interval, and differentiable on open interval AB, there must be some value C between, and I'll go ahead and put that here, a value C between A and B, such that f of B minus f of A, over B minus A. So the derivative at that value C is equal to the slope of the lines connecting those points. Let me just go ahead and draw a typical graph. I don't know, maybe something like this. And if you have a point here A and a point here B, and we're saying that there's some value C, I don't know where, let's go ahead and draw this first. So there's f of A, and there's f of B, and if I connect those points, this mean value theorem says there's some point C in that interval, and I better go ahead and just find it, that has that same, it would probably be maybe about right there. So C would have to be right here. That has the slope of the tangent line at C is equal to the slope of the line that connects the endpoints. Okay? But now that leads us into the average rate of change of a function. The average value of a function. Okay? So this is what it is. The average value of a function, and I always call it fav, f average, is equal to 1 over b minus a multiplied by the integral from a to b of f of x dx. And so that's the average value of a function that's continuous and differentiable. And I think it will make more sense when we go ahead and work this first problem. So we're just going to use that formula. And this is from A to B, and f of x is continuous on closed and differentiable on open. Okay? So let's try to do that. Find the average value of f of x equals 6 minus x squared on the interval from -1 to 3. Okay? So let's go ahead and find that. F average, or I call it fav. Anytime you see average value, you want fav. These are the magic words. Many students find the average of the values of the endpoints, and that is not correct. Anytime you see average value, I want you to write 1 over b minus a, 3 minus a -1, times the integral from -1 to 3 of 6 minus x squared dx. okay? So let's go ahead and find that. That's 1/4 multiplied by 6x minus 1/3 x cubed, evaluated from -1 to 3. I didn't leave you much room, did I? And that's 1/4, and I'll let you compute. I'll let you compute that, but you should get what? 18, plugging in a 3, 18 minus 9. I'll go ahead and write that. And then minus a -6. What would that be? Plus 1/3. And I got 11/3. Now, just so that we can look at it on the graph, that's equal to 3 2/3. And we're going to talk about what that means over here on this graph. So the average value from -1 to 3. So if we integrated this function from -1 to 3, okay, and that area under the curve, basically what this says is that this integral is equal to some y value multiplied by the width of the integral. So at 3 2/3, so at about right here, from -1 to 3, average value says that this area is equal to the area highlighted in yellow. So the average value, which is fave right here, that's fave, that y value, is the value that when multiplied by the width of the integral, giving you that area. So think about multiplying both sides of this by b minus a. So the area under the curve from -1 to 3 is equal to this multiplication of a height and a width of a rectangle. It's really cool. Now, you might be asked, what is that value? What is this value right here that goes along? What is the x value that goes along with that fave, that y value? What is c? So find c when f of c is equal to 11/3. Okay? What is that x value on that graph that corresponds to our average value? Okay? So find c when f of c is equal to 11/3. So f of c is equal to 11/3, and f of c is 6 minus c squared. So we would have 11/3 equals 6 would be 18/3 minus c squared. So we're going to get c squared is equal to 18/3 minus 11/3. So c squared is 7/3. So c is plus or minus the square root of 7/3. That's about equal to plus or minus, and we're going to go ahead and take the plus, but look, we're going to go ahead and take the plus one because we're over here on the right in our interval. There are actually 2 points, but in our interval, on -1 to 3, c is equal to a positive root 7/3, which is about 1.578. Okay? So, now let's talk about the mean value theorem for integrals. And that's really this same thing that we just talked about, the average value of a function. So f of some value c is equal to 1 over b minus a multiplied by the integral from a to b of f of x dx. I have always said in the past, f of c equals fav. That has helped me so much. There is some c value that has a y value that's equal to the average value. Okay? So this should look very similar, except we had the average value here before. Okay? Again, AB, f of x is continuous on closed and differentiable on open, and continuous on closed, differentiable on open, and I'll go ahead and just leave that there. And then remember that C is somewhere between A and B. Okay, let's go ahead and compare the average rate of change and the average value of a function. This is a great problem to talk about. So we have h of t is equal to negative 16 squared plus 41t plus 10. H is the height in feet, and t is the time in seconds. We are not solving this. We are just setting it up for each question. And then we'll also talk about the units. Okay? What is the average height during the first 3 seconds? So the thing you need to know is we're on the interval from 0 to 3, and here is our function. So the average height average is equal to 1 over 3 minus 0 multiplied by the integral from 0 to 3 of negative 16t squared plus 41t plus 10. And you can simplify that as 1/3 multiplied by the integral from 0 to 3, negative 16t squared plus 41t plus 10. Whoa, dt. Did you see that? dt. Okay, so that's what that is. And what would that be? If height is feet and time is seconds, these would be feet. This average value would be feet. Okay, how about the average velocity, right? Average height is an average value. Anytime you're asked about the average value, that's fav. But average velocity is different. That's equal to h of 3 minus h of 0 over 3 minus 0. And we're just setting that up. And those units would be feet per second. Okay? Okay. So we're going to go ahead and look at this next problem. And we see that r of x is equal to 2 sine of x minus 1, and r is the rate in which this gentleman's waistline is changing in inches per month, and x is in time months. What is the average rate that Mr. Bruce waistline changes from the 10th to the 12th month? Okay, that is the average of our function, okay, because that rate is the function. So this is going to be average value of that function. So that'll be R average is equal to 1 over, and we're from month 10 to 12. So it is 1 over 12 minus 10, and let's go ahead and write that down. 12 minus 10 multiplied by the integral from 10 to 12 of 2, sine of x minus 1 dx. And we can go ahead and simplify that as 1/2 multiplied by the integral from 10 to 12 of 2 sine of x minus 1 dx. And our units, now think about this, are in inches per month, okay? Because those are the units given for r of x. Now, average rate of change, that's slope. When you want the average of change, that's slope. Is f of 12 minus f of 10 over 12 minus, it said during the first 5 months. Yep, I need a new interval. That is going to be 0 to 5. So it's f of 5 minus f of 0 over 5 minus 0. And you guessed it, it is r of 5 minus r of 0 over 5 minus 0. So I can just simplify that as r of 5 minus r of 0 over 5. And think about these units. This is inches per month, so it's per month squared. And that concludes part 2.